Hi, this is Victor and welcome back to my math tutoring channel. In this video, we'll study the sequence an equal n factorial divided by n to the power of n. We will see if it converge or diverge. And the technique that I will use is the squeeze theorem. Looking at my sequence, as n goes to infinity, my numerator goes to infinity and my denominator goes to infinity. But here I cannot use the hospital rule because I don't have a function. So the only thing that I'm left with is to write few terms of that sequence. If I take n equal to 1, so I would have my a1 is equal, 1 factorial is 1 divided by 1 to the power of 1 is 1, so it's equal to 1. If I take when n equal to 2, 2 factorial is equal 1 times 2 divided by 2 to the power of 2, which is 2 times 2. And if I take n equal to 3, I would have 1 times 2 times 3 divided by 3 times 3 times 3. And my last one that I'm going to take before I generate my terms, if n equal to 4, it's 1 times 2 times 3 times 4 divided by 4 times 4 times 4 times 4. So I can have my general term an when n goes to n equal 1 times 2 times 3 times 4 times till n, but I have to divide it by n times n times n times n. So from here I can see that I can factor out, first let's factor out 1 divided by n. I will have 2 times 3 times 4 divided by n times n times. So if I want to draw my sequence, I know for a1, for n equal to 1, my sequence start by 1. An is equal to 1, so that's my first point. When n equal to 2, I would have here 1/2. So let's say 1/2 is here. And when n equal to 3, I will have 2 divided by 9. It's like less than 1/2, somewhere here. For n equal to 3 is here, and when n equal to 4 is here, and I see that it's approaching 0. So if I want to draw it, I will draw it like this, yeah? So it's approaching 0, but it will never be 0. So I know my an is between 0, I can put or equal, but it can go to 1 over n. And because like this is like whatever is between the parentheses is less or equal than 1. It can be 0.000, but like it's always less than 1. And I know 1 over n, when n goes to infinity, it is 0. So that's why I put between 0 and 1 over n. And I know like 0 factorial is equal to 1, so that's why I did not start with 0, and a factorial of a negative number does not exist, so I started by 1 to infinity. So now we know that 1 over n, when n goes to infinity, that goes to 0. 1 over n, 10 goes to 0 when n goes to infinity. So now by the squeeze theorem, I know that my an goes to 0, because like if this goes to 0, I have 0 less than an, less or equal than 0. So by the squeeze theorem, I know my an goes to 0, and so it converges. If you like my video, please subscribe to my channel. That would help me tremendously, and it will encourage me to do more videos for you. And if you push the like button, I would really appreciate it. Thank you for listening.